Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem which is print diagonally. So what we have to do is we have to actually not print in a diagonal order but in an anti-diagonal order from top to bottom. So what the question is mentioning is, let's suppose you have this particular given matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So firstly, anti-diagonal element should be this, then this, then this, then this, and then at the end this. So this is what it meant. So you have to print it in this way. So this is the arrow direction which is pointing from here to here. So we have to do print that. So let's suppose 1, then 2, 4, then 3, 5, then 7, 8, then 7, 6, then 8, 9. So one thing which is to be noted here is that these are the indexes representing each element. So what we can now do is, so 1 comma 1 is basically 0 plus 0, that is 0. Then 2 is basically 0 plus 1, that is 1. Then 4 is basically 0 plus 1, that is 1. Then 3 is basically 2 plus 0, which is 2. Here you can also see 1 plus 1, it is 2. And then 0 comma 2 2 comma 0, then it is 2 already. Then here for 6 it is 2 comma 1 comma 2, so it's 3. Then here it is 2 comma 1, again 3, and then at the end here it is 9. So 9 is basically 2 plus 2, 4. So you can see that the summation of this index are like this. Firstly it started with 0 and then it goes till 4. So 4 is what? Let's suppose we can see that this is a 3 cross 3 matrix. Then what we can conclude here is that let's suppose some integer t which is going to be representing the upper bound of upper bound of the sum, then it should be 2 into n minus 1. So n is basically 3 here, so we can do it like this. So t is basically 4 here in this case. So now this is the thing which we have to do. So how we can do this problem is, let's suppose we are making a vector v of size t plus 1. So in this, so this is a 2D vector, basically you can say it like this, a 2D vector. So at each index, so let's suppose at 0th index, so what do? We just append only 1. So at 0th index we append only 1. Then at 1 index we append these 2, and then at index 2 we append these 3, and at index 4, let's suppose index 3 we append these 2, and at index 4 we append these. And at the end what we do, we just traverse each element of this vector, and then we add this all the element of this vector into our answer vector. So this is the approach which we are going to follow here. So let's suppose t is basically 2 into n minus 1. We can make it like this to be more precise. And then vector, so this is a 2D vector of size t plus 1, let's suppose. So what we are doing here is that let's suppose from int I equals to 0 till n and j equals to 0 till n, at the index vi plus 1 we push back a of ij. So why the element would be in this order? Because we are starting from 0, I equal to 0, and we are traversing this. So we are firstly going to have 2 as our answer, and then only we have 4. So the order of this should be preserved. That is, firstly 2 comes, then 4 comes. And after that what we do, we just make an answer vector, and then we just assess. So v is representing the size of the vector, and then vi dot size is representing the size of the nested vector inside that vector v, and then we just push back each and every element inside our answer vector, and then at the end we are going to submit this. So yes, this is the approach to solve the problem print diagonally, and if you want to access the code, then you can check the GitHub link given in the description. But before going, do like, share and subscribe to this channel. And this is it. Thanks for watching.